Hi everybody, Mr. Rubo here, and today we're going to look at polynomial and rational inequalities. So, there's a couple warm-up questions here, kind of just getting you in the mindset of it. Go ahead, take a second. It's true or false. Give an answer, and we'll go over it in a second. Okay, so hopefully you paused the video and did the question. So here it says the graph of the function is below the x-axis for 0 is less than 2 is less than or 0 is less than x is less than 2. So here is 0 to 2 in the x direction. Is it below? Yes. Now, it's not the only spot that's below, but the question itself is just, is it below? The answer is true then. All right, then when you look at this one, the graph of f of x is above the x-axis for 2 is greater than x, which I would rewrite that as x is greater. Rewrite that as x is less than 2. So if you think of it that way, here's 2. X being less than as you're looking this way. We are not above, we are below. So this is false. Okay. All right. So now we're going to solve those same problems, but we're going to do it algebraically. So we're going to use one of those sign charts we did in quadratics, but we're going to use it with polynomials here. So you have to find all three zeros, or all the zeros that are there. So x is going to give us a 0 at 0. X plus 1 is going to give us a 0 at -1. X minus 2 is going to give us a 0 at 2. And it is a number line that you're writing here, so it is important to put them in numeric order, right? From left to right, negative, 0, positives, right? So now we're going to do where you kind of have a choice, but what you want to do is you want to plug in numbers in each of the sections. So I'm going to look at this number line and think of it as kind of breaking it up, and there's numbers in each of these sections, so I can plug them in and think of it that way, and then I'll kind of talk about another way of thinking of it as well. So if I think of a number that would be on this number line to the left of -1, I would say -2. So if I plug in -2, I go ahead and start simplifying. Simplify what's in the parentheses first, so -4, that'd be -1 and -2, and then it's all multiplication, and really all I care about is that it's negative, but you can figure out, oh, it's -8. That was not an 8. There we go. So this section is negative. Oh, my spot stylus is not working right here. Oh, sorry about that. Accidentally hit the next page button. All right, so now you go to the next section. Now this next section is the hard one because it's not there's no integer in there, but you just plug in 1/2, and again, you don't even have to simplify it fully. You just need to know, is it positive or is it negative? So I'm just going to erase this so I have some more room, and I'm going to do -1/2 because that is between 0 and -1. Okay, and all right, so now I start simplifying this, and I get -1/2 times, that's +1/2, and then this would be -2 1/2, which is -5/2. Then I would leave them as improper fractions, makes it much easier. And again, you really don't have to do the multiplication. We just care about how many negative signs there are, which means this is going to be a positive. But again, if you want to see it, it's +5/8, which means between 0 and -1, we get a positive answer. And we're going to keep going into the next section. So the next section is 0 to 2. Well, a number between 0 and 2 is 1. So that's what I'm going to substitute in. So 1, 1 plus 1, 1 minus 2. Start simplifying. That's 1, that's 2, that's -1, which means we get -2, which again, all we care about is the sign being negative. And then the last section here, 2, and then bigger, so I'm going to substitute in 3. Thought I switched colors, but I guess I didn't. And it's too late now. I've already gone too far. So that's 3, that's 4, that's 1. You get positive 12. So you get a positive answer. Okay. So here, you can see the sign chart is complete. Now you look at what we care about in terms of comparing it to 0. We want less than 0, which means we want negative, because less than 0 means negative, which is this section and this section. So again, I would write this in interval notation, negative infinity to negative 1, and it's exclusive, so parenthesis. And then there's a second part, 0 to 2, and again, they're both not included because it's less than 0 and not less than or equal to. And there's your answer. Okay. So, and that, if you look at above, 0 to 2, which is our second interval, was negative. Here we have another 0, and this part was positive, this was negative, and then this was positive. That's our sign chart. So again, that's how those relate to each other. So if you do it graphically, fine. If you do it algebraically with the sign chart, 100% fine. Okay. The other way you can also do this, and it's a nice shortcut, if you will. You still have to substitute at least one value in. So let's say you went ahead and you substituted negative 2 in. Well, if you think about the multiplicities of each one of these things, so at negative 1, the multiplicity is 1, that means that you are changing whenever you have an odd multiplicity. So in other words, since this was negative on the left side, it'll change to positive on the right. Then x also has a multiplicity of 1, which means since it was a positive on the left side of 0, it's a negative. It has to change on the right side. And then again, 2, multiplicity of 1. So again, you were negative, it becomes positive, and it requires a lot less substitution. All right, so I just want to go, so I'm going to skip 2b because 2b is basically the same thing as the graph above. I want to go to this one just because then we have something with a multiplicity of 2, so you can kind of see this shortcut. So 2 zeros, we got 5 and negative 2, so negative 2 comes first. Okay, and so now let me substitute in a number. And again, you can actually choose whatever number you want in any of the spots. So you can choose like negative 3. We could choose something between negative 2 and 5. We could choose something bigger than 5. You just can't choose negative 2 and 5 if you're going to use the multiplicity method. So, and actually, I like to do this as well. I like to throw multiplicity of 2, and this has a multiplicity of 1. Okay, so now let's go ahead and choose a number to substitute in. Just for the sake, I always like to do the left side. It's just how I am. It may not be the easiest number to substitute in, but I'm going to choose a number to the far left, which would be negative 3. And don't forget the squared, because that's very important. So if I start simplifying, negative 8. This is negative 1, but it's being squared. So this is positive 1 times negative 8. So this is negative. Okay. So now this is where the multiplicity method comes in. Since this is negative, multiplicity of 2, 2 means you would bounce. And another way of thinking of it is if you're bouncing, that means you're staying on the same side. So in other words, if it's negative, it stays negative. And then multiplicity of 1 means once you hit 5, it's got to change. So negative would become positive. And I was able to do this whole sign chart without plugging in numbers. And this multiplicity method is the way I prefer. It's quicker. But again, if you don't like it, substitute numbers in, right? I substituted negative 3 in. I would substitute 0 in if I was looking at the middle section. And then I would substitute like 6 in for this last section. But then we have to actually do our answer. So greater, didn't change colors there. Cool. There we go. Greater than 0 means the positive. So there's only one positive here. So that would mean 5 to infinity. infinity. Oh, my stylus really doesn't want to write right now. There we go. And again, exclusive because it's greater than and it's not greater than or equal to. And that's your answer. All right. Go ahead and try 4. And yeah, then we'll go on to rationals. The answers are on Canvas, so take a look at that. All right. So now, similar questions here. True and false, but this time we're looking at rational graphs. So when you look at this, it's asking is below the x-axis, and again, I don't like that they wrote it that way, so I'm going to flip it and say x is greater than 1. So here is x is 1. We're looking to the right because we're looking at greater than. It is below for part of it, but then it jumps above. So that means this is false, because if it just says x is greater than 1, then it's the whole, everything to the right, which that is not true. It's not all below. There is part that is above. And then this is another tricky one. Here, a graph of this is above the x-axis for the interval negative infinity to infinity. And you might be like, oh, well, the top or the left side is going, right side is going. So that means it's true, right? No, this one is actually false. The reason why is because at 1, you can see this dashed line means we have a vertical asymptote, which means there is no point value here, which means we're not above the x-axis, we're not below the x-axis. There literally is no point at that at x equals 1. So really, we're above it from negative infinity to 1, and then 1 to infinity. That would be the correct interval notation. And that's a parenthesis. My stylus is just being really weird today. So that is why this one is false. Okay. So let's go ahead and we're going to look at this and how to solve these ones algebraically. And I guess I should have pointed out with polynomials, if it's not factored, you'd have to factor it. We're going to give it to you factored pretty much the whole time. Or it'll be something that's easily factorable, kind of like this one, where all you got to do is that difference of 2 squares. Okay, so now the way the sign chart works here is you have stuff in the denominator and in the numerator. You have to take all of those into account on your number line. So if you look, we have -2, we have +1, and then we have +2. So it's all the parentheses involved. Okay. The one thing you're going to want to do, though, is anything that came from the denominator. So in this case, the 2 2's, the -2 and the +2. I put a VA underneath them because they are representing vertical asymptotes, which means they are not included ever in our answer. In other words, they're always parentheses, just like infinities. And then what I do too, just to have kind of where I like, oh, I don't forget to label anything. 1 in this case would be an x-intercept. And yeah, I like to label it. The other label that you might have would be a hole, which would be like 2b has a hole. And yeah. All right, so now, just like before, you're going to substitute in some number. So in this case, I'm actually going to choose one in this middle section. I'm going to choose 0. So I choose 0, start solving this, so I get -1 over 2 times -2, which means I get -1 on top, -4 in the denominator. 2 negatives make it a positive, and so I put a plus sign where 0 would be, which would be in between -2 and 1. And guess what? I can use my multiplicity trick even with rationals. So the x plus 2 gave me the -2. It was to the power of 1, so that means its multiplicity is 1. This one, again, multiplicity of 1 and multiplicity of 1 for all of these because, again, their powers are all 1. So now knowing this, I can fill out this whole sign chart without any more work. I just have to know, okay, if I work backwards to the left, this is a multiplicity of 1, which means it has to change. Well, if the right side is positive, the left side has to change, so it's negative. And then kind of the same idea here. This is positive. Here's 1. Its multiplicity is 1, so then it changes to a negative. My stylus didn't want to mark that. And then another multiplicity of 1, so it's changing from negative to positive. And again, if you don't like the multiplicity route, just substitute numbers in throughout. And then again, our last part, once we have the sign chart complete, look back at what we were looking for. And we want less than 0, which is this one, and write our two intervals. So this is all the values from negative infinity to negative 2. And I don't even have to look back. If this is a vertical, it's got to be a parenthesis. The only one you have to be careful with is the x-intercept. You have to look back and say, oh, it's less than, so it's parenthesis. So it'd be parenthesis 1, parenthesis 2. And there you go. Oh, that's not what I did. Okay, I don't know why it's being stupid. All right, so all right, we're going to do 2 more of these, and I'll leave the last one for you is kind of a challenge problem. So here, we're going to go ahead, and this is where you have to be not careful, but you just, this whole is going to make things a little bit more difficult. So again, we start doing our number line. We have positive 3, positive 2, and then negative 1 as a whole. So here we go. Okay, so now this is where wholes get weird. So let me change colors, make it green. So that's a whole because it would cancel out, right? So that's how we know it's a whole. 2 is our vertical and 3 is our x-intercept. All right. Multiplicity of 1 for the vertical, multiplicity of 1 for the x-intercept. The whole happens twice in this, which means that you can almost think of it like a multiplicity of 2. So it ends up that if it's positive, it'll stay positive. If it's negative, it'll stay negative. Okay. So let's go ahead and plug in some numbers. Again, you could choose whatever number you want as long as it's not one of the numbers on your number line. So again, you can choose 0. It's really up to you. I'm going to choose 0 in this case. So now, oops, I forgot the fraction bar. So top, you get negative 3. Bottom, you get negative 2. So that's 2 negatives, which means it's positive. And again, this whole, you end up getting where it stays positive. Okay. And then multiplicity of 1 means you change. Multiplicity of 1 means you change. Okay. So when you think about this one, you just have to be careful with that whole. And if you're unsure, just plug in numbers on both sides and see if it is that case. And then now we say greater than 0. Again, wholes and verticals, it doesn't matter. You never include them. So even though like we have 2 positives next to each other, because this is a whole, we do have to write 2 separate intervals. So negative infinity to negative 1, union negative 1 to 2, and then we also have this one way out here, so 3 to infinity. Okay. So yeah, there's your basics of rationals. 3 is really no different. It's just or equal to. So when it comes to this one, actually, we'll do this one and maybe start the next one. So here we have negative 2, 1, 3. Let's plug in 0. And you get negative 3 times 2, which is negative 6 over negative 1. So we get a positive answer for when we plug in 0. These are all multiplicities 1. Again, I should have labeled these to begin with. This is x-intercept. This is a vertical x-intercept. Okay. And so now multiplicity of 1 means I'm switching every time. So if this is positive, to the left of it is negative. Positive to the right of it is negative. This is negative, so to the right is positive. You just keep switching. And now this is where rationals become a little bit more difficult, is because when you have or equal to, so less than means the negative, or equal to means I include the x-intercepts, the zeros. Okay, so in this case, I would say negative infinity to negative 2, parenthesis around negative infinity, but negative 2 is an x-intercept, so I include it. Union, now 1 is a vertical, which means it's always a parenthesis. So that's where it gets a little weird with rationals. 3 is back to being an x-intercept, so you have to put a bracket. And that's the part where mistakes do get made with rationals. So just be careful with that. And then number 4 here is just throwing a something not congruent or not compared to 0. So you have to compare it to 0. So my first step is, that's an x by the way, is subtract 1. So now I have to combine this into one term, so I have to get a common denominator. So I'm multiplying the numerator and denominator by x minus 4, which because it's 1, it doesn't do anything other than write itself x minus 4 over x minus 4. All right, and now you have a common denominator, so x minus 4. And now you just have to be careful. So it's x minus x, so actually the x's cancel. 2 minus negative 4, so you get 6. And you get this lovely rational function. And the nice one with this is there is only one thing with an x, one factor, which means you get 4 here. Plug in 0 and you get 6 over negative 4, which means you get a negative here. Its multiplicity is 1. It's a vertical, and it's negative switches to positive. We want just positive. Even though it's or equal to, this is a vertical, so we would say 4 to infinity, and parentheses around both, even though it says or equal to, and it's all because it's a VA, it's a vertical asymptote. Okay, well, thanks for watching, and have a good day.